So what's going to happen this afternoon, the first step of this afternoon is we're going to have 18 companies present their business pitches. We're going to have our panel of investors who you had seen earlier, ask them questions, and we're going to cycle through this until we do all of the companies. So that's a prelude in some sense for the one-on-one meetings between the investors and these companies. So we have a separate room set up in the back corner of this building. You go down this corridor and all the way to the end, through like a cafe area, all the way to the end in the Danforth room is where there will be the one-on-one meetings between the companies and the investors. Each company will have an assigned table, and then we will have a digital sign-up sheet for the investors to sign up for individual time slots. Some of those time slots have been pre-filled in by the investors who did their homework before they showed up today. But every investor in the room, open up this QR code so that you can go to the spreadsheet, and as you hear a pitch and you want to talk to this company, fill it in. We're not going to continue to the next step until I see every investor open up this QR code. I mean it. All right. So, everybody's welcome here for the pitches. The one-on-one meetings is between the investors and the companies. While that is happening, though, fear not, you will be well educated and entertained, because while the one-on-one meetings are happening, two other things are going to be happening here and across the hall. We're going to have a research showcase, power pitches, is that what we call it? Yeah, power pitches. We're going to have our faculty talk about their research. So some of the coolest research going on the planet is happening in this campus. You're going to hear about some of that. Across the hall is going to be like an expo area of cool technologies that you can see and touch. So I'm sorry, judges, that you're going to be off meeting with these boring startup companies when you can be hearing all this cool research, but you're going to have open slots too, so you'll be able to come back and forth a little bit. It's a little bit of a commute because it's the other corner of the building. All right, did I stall long enough that all of the investors have opened the QR code? All right, moving on. I don't think we're putting this back up again. So if you don't, it comes up again later. All right, good. All right, I'm trying to be mean, but all right. So here's the order of presentations. This also will be repeated. So unlike last year, we don't have to remember from the first slide. So we're going to try to stay tightly to this schedule here. So each presenter will have 4 minutes to present. There's a clock down here that they can see. It says 4 minutes when you start. It's going to tick down. When it gets to 1 minute, it's going to turn yellow. And when it goes to 0, I'm going to shoot rubber bands at you or something. I don't know, but like cut it off. If you have technical details, technical issues or something like that, we'll be a little flexible about the turn-off time. But otherwise, like, we want the trains to run on time because we have a lot of things to get in here. All right, so intentionally blank. Flow Solutions, your slides are up here. And come on up, and I'm gonna go down there and get my rubber bands ready.
All right, hi everyone. My name is Becca and I am the CEO and founder of Flow Solutions. We make flow battery monitoring and diagnostics for a more reliable energy storage future. Only 2% of the energy storage we need by 2050 exists today. And we know that the sun doesn't always shine and the wind doesn't always blow. And with 90% of electricity production by 2050 being renewables, we need inexpensive energy storage now. We know lithium-ion batteries are in your phone or electric vehicle, but they're also being used for short duration charging times on the electric grid, and the price will approach $100 per kilowatt hour in the future. However, the flow battery becomes cost competitive at these long charging times, which is exactly what we need for the electric grid. And if we want to prepare for tomorrow's reliable electric grid, we need more advanced batteries now, which is why the flow battery is the technology we should be looking at. However, there's quite a few critical pain points for flow batteries, such as data management, diagnostics, and sensors and monitoring, with the key challenge here being that without a complete diagnostics framework, flow batteries will never get over the high cost of inefficiency and operation and maintenance and will demise from unexpected failures. We offer the flow solution to unlock the potential of flow batteries for a more reliable energy storage future. First part of our solution is diagnostic software, where we offer performance modeling to improve the battery efficiency and extend lifetime. Next is the sensing hardware, where we have novel sensors with enhanced sensitivity and accuracy. And last is the flow battery database, with enhanced modeling for all customers and attracting external stakeholders. The market for flow batteries is hundreds of billions of dollars, and we're targeting the $45 billion flow battery diagnostic space. Our customers are flow battery manufacturers who have enough bandwidth and capability to be making their systems cheaper and more efficient, but they're not able to hire internal software teams to make this happen. We at Flow Solutions are the only company making flow battery-specific diagnostics, and the heart of this is in our localized sensors, where we're able to bring in flow battery expertise and big data science expertise to create the toolkit needed to push flow batteries into the future. Our go-to-market strategy started with over 130 customer discovery interviews and proof of concepts. Next, we're currently forming pilot partnerships and launching our MVP. The next step will be selling our software as a subscription model and then selling our sensing hardware to the same customers already acquired. Our final launch will be for the sensor database, and we'll be in a good position to be acquired by some of our customers who find us most valuable about 8 years down the line. We're forming beta testers, collaborations, and research collaborations right now. If you have more questions about it, please pull me aside afterwards. And here is our Flow Solutions team. I'm Becca, a PhD student at the University of Pittsburgh, and our team has deep expertise in batteries, energy markets, and engineering. Here is our ask, and I'm very excited to speak with you later about our Flow solution to unlock the potential of flow batteries. Thank you.
Thank you, Becca. So panel, please go ahead with questions.
Thank you.
What is your moat? Any IP on the sensors?
Yes, so we have a patent pending for our sensor technology, our currently favored sensor technology, and then we'll be developing more patents throughout the remainder of my PhD. And so we plan to create a moat of our sensors individually in the sensor platform and then overall with our platform design. And then our software will be confidential, as is industry standard for flow batteries.
Can you talk a bit more about the business strategy and pricing model?
Yes. So our pricing model is so we are looking at selling the diagnostics software at a 5-year warranty with a 10-year lifetime, and the sensing hardware, the costs are seen above. The sensing hardware, some of the biggest components there will be installation, which will help with, but the individual sensors are not going to be incredibly expensive.
How do you adapt the technology, or 2 different technologies? So you got iron flow, vanadium, all these different, very different chemistries, very different technologies. How do you adapt your technology to it to give information that matters to the operators?
Yes, that's a good question. So our sensors are chemistry agnostic. The sensors that we connect directly to the battery electrolyte will not degrade with any sort of aqueous solvents, and so we can calibrate it directly to either vanadium or iron or even zinc technologies for hybrid flow batteries. Did that answer your question? Thanks.
All right, thank you for your presentation.
Thank you.
Next up is Cisum Tech.
Hi, everybody. Reed, thank you, and really great to be here. I am Randy Eager, CEO and co-founder of Cisum Tech. We are a Carnegie Mellon spinoff. We're focused completely on rebuilding the U.S. solar supply chain by producing silicon wafers. This is for the solar industry, silicon wafers on a continuous basis, cutting costs and CO2 generation in half, and produced here in the U.S. By now, I think we all know solar power is really the least expensive way to produce energy. What you may not know is that around 70%, or we're reaching towards 70% of the new power generating facilities will be based on solar. But unfortunately, there is a dirty secret, several of them in the solar industry, and that is 97% of all wafers do come from China. And much of the raw material that is used to produce that is created with forced labor. The other dirty secret is not so dirty. It is 50 years of experience here in creating silicon wafers, for the chip industry. These are the round wafers that you're all thinking of. The solar industry produces rectangular solar panels and uses rectangular or square wafers. So that process is what creates 40% scrap. And of course, in generating 50 to 60 million tons of extra CO2 in that process. As an eye chart, but this is the very long, arduous, two-step manual process that's being done today. 14 steps, 40% scrap. Our process, much more simple. We start with polysilicon, raw material in one end, in a ribbon of polysilicon, of silicon. There's a wafer out the other end that is the right width and right thickness, and we trim to the right size. This whole process is continuous, and through process automation, completely automated all the way through to packaging. So this is a very straightforward process. Many companies have tried to do this before. Eric Yitzi, who's CTO, founder, emeritus faculty here, he and I are working this full time, and another employee, but he has spent 10 years knowing that this has not worked at other companies, and thanks to his work and three very gifted grad students have found the problems and solutions to those historical problems. That's the process that we are scaling today. During that time, there's 2 issued patents as well. Giant market size. This is bottom-up look at the dollars here. $2 billion last year purchased in the U.S. of silicon wafers for the solar industry. Growing like crazy. Mostly thanks to the motivation incentive from the Inflation Reduction Act, which we talked about earlier, certainly. 26 companies are expanding or adding new facilities or creating new facilities here in the U.S. We all know about the energy crisis in Europe and many other things that have added tailwinds. Our go-to-market strategy, really straightforward. We're a B2B company. We expect to be producing wafers and building a 1 gigawatt plant. Here's a simple look at financials at scale. We all talked earlier about it being very important that this is a real business. At scale, 120 million in revenue, roughly 20 million in EBITDA. This is a real business, but it it's really an amazing thing to see 60 million in IRA tax credits for such a business. But
All right, thank you, Randy.
here's the team.
Shooting rubber band at you.
Sorry,
can
this
ask
is
about
my
your team.
this is my 5th spinoff from Carnegie Mellon. Sorry, thank you.
Randy, good to see you again.
Jason, good to see you as well. I received a no from Jason. I'm one of 1,800.
Not a no, it's a no for now.
It was a comeback later. Yeah.
Yeah, right, so that was going to be my question. Two things. One, maybe it's worth telling people that, you know, your repeat founder experience that was skipped, but I know Reed's keeping everybody on time, which is
Yeah,
great.
Reed's tough.
And then,
Put that slide up while he's talking, though.
yeah, well, you can.
Sorry, thank you, Reed. You're
And
the
then,
man.
second, can you tell us about the state of the technology?
Sure. Yeah.
today.
For me, the last 25 years have been in and around the Pittsburgh startup scene. 5 years on the investor side with Innovationworks. I see Jeff here. Again, this is the fifth one, 2 exits, and the others are still going strong. I'm just a co-founder, board member, advisor. My early days, BASF, about 10 years building a new business unit there with a new material. Learned how to be an entrepreneur. I guess we call them entrepreneurs, but learned how to do that there with somebody else's money. It was wonderful. And just fell in love with clean tech, and most all of these companies have been under that heading. Certainly materials oriented. They're all materials companies.
And how about the tech? Where's
Yeah,
it at?
the technology, it's funny you get back to that, is we're still incubating. So license is done, incubation agreement is done. If you know Carnegie Mellon, we're B-level Doherty Hall. The machine is up and running. This is version 2. And unfortunately, we're still pre-seed. I don't have a wafer to hand to you, which is when we're going to come back to visit. So we're much closer. We're working on closing this 800K round, pre-seed round, but we're still there.
Great, thanks.
We're over time, but I'm gonna let one more question, like quicker answers.
Sorry.
Aside from funding, what else do you need help with right now?
We need help, like everybody. Of course, we could use some more introductions to people who would interested in being an investor. Obviously, that's one side. The other side is getting to know the industry even better. Any introductions to folks in the solar industry would be helpful. I do attend the conferences, even got to present at one of the solar conferences. So we're doing our best.
Next up, People's Energy Analytics.
Hi, everybody. My name is SCHO, and I am the CEO and founder of People's Energy Analytics, which focuses on reducing unpaid energy bills while improving revenue recovery in electric and gas utilities. There are over 7 million people whose energy is shut off due to non-payment. If this person doesn't look familiar, right there, that's me in my rental property when my tenants were working really hard to save money on their bills, saved themselves about $200 that month, cost me about $30,000 in damage to the kitchen, the bathroom, all the floors, and that doesn't even include the cost of the plumber who said his job is not to replace any of the walls he had to cut into to get those pipes fixed. Now, the thing is, we know there are a lot more people facing these challenges every single year. 25 million households in the United States are behind on their bills every year. This leads to utility companies being indebted $16 billion a year, right? So that's an upper bound on our market size. Now, just to find these households, we estimate that the minimum market size is about $2.5 billion just in trying to find and get these people signed up to assistance programs. Now, you might be asking, aren't people trying to solve this problem already? Yeah, they use disconnections saying, hey, if you don't pay your bills, we're gonna cut you off. But what happens is there's years of abnormal energy use, customers miss payments, they default on their bills, and the utility disconnects them. Our competitors, Power and BlastPoint, they come in after customers start missing payments and try to get them connected to assistance programs. But through my research here at Carnegie Mellon, where I'm also a professor and working with my students, we actually can identify vulnerable customers years before they ever miss a payment and get them connected to assistance programs. So our full service solution first uses our proprietary patent pending data analytics algorithm to find these households. Then, because we can do this at the individual level, we then market personally to these households, and then we will enroll them into customer assistance programs. To give you a sense about what this customer classification dashboard looks like, here is an output from one of our analytics runs in the Chicago area. And this is what some of our competitors would also do, try to identify the zip codes where there's high financial risk. But the beauty of our algorithm is that we identify multiple types of risks here. So here in the red, I'm showing you high financial risk. The blue is pipe freeze risk. One thing you'll notice is that our competitors would tell the utility, go talk to every single household in this bottom red quadrant, right? But the reason that they miss all those northern households is because, like my tenants, they're trying really hard to make sure that they can afford their bills. And so now we can identify the different types of risks that people are potentially suffering from. And then the other secret sauce of our algorithm is, again, getting to this account level. So now instead of telling the utility to go talk to every single house in a zip code, we now will give them the specific accounts and the addresses that they should talk to, and we use that for individualized marketing, which is much more effective. We then also track the workflow management of this because by law, anytime a utility disconnects and reconnects a person, they are required to go out to that household at least 3 times to check up on them. It's very expensive for the utility. They would prefer not to have to do that, but also not to have to redo any work that wasn't recorded properly in the first place. Our traction is pretty strong. We have had 2 successful pilots in 2023. And we also scaled our algorithm to be able to look at over 1 million households. We plan to have 2 complete paid business pilots by Q4 of 2024. My team spans myself, I'm a professor here, as well as expertise in the marketing and business space. And our specific ask is currently we're raising 1 million, our round is 50% subscribed, and we're closing it in July of 2024. So once again, People's Energy Analytics focuses on reducing unpaid energy bills while improving revenue recovery in electric and gas utilities.
Right on time.
So my question is, could you remind me exactly where you're getting the data from?
So we get the data directly from the electric and gas utilities. So when we are running our algorithm in this slide here, these account numbers, I've whited them out because I'm not going to jail for effective presentations, right? But that account number is coming directly from the utility. We get the energy usage data from the utility. So our competitors typically use credit card information, but we're actually using actual energy usage data from each and every household, and we run our algorithm on individual households.
I'm just wondering, how are you able to get them and your competitors, I guess, are not?
One, it helps I was a professor, and I did this starting off as a research project. So the thing is, I am known in the energy poverty space, and I went to utilities and I said, you know, you guys assume everyone uses as much energy as they want to in their home, and that these people using very small amounts of energy are energy efficient. But what I did in my research was I actually showed that this is not the case, that these are poverty households, and they're at risk. And so then I was able to get in that way. And then, you know, with the utility space, having those introductions is very, very important for that data sharing.
So given your expertise, we have utilities as LPs and around us. The 16 billion, they wouldn't say it out loud, but they don't care because they socialize it. But they do care about disconnects because the bad PR, and they're people and it hurts people. There is a market there. The question is, so you've identified them, what are you going to do? Because that's what they don't know either.
Right. So so right now we're currently in negotiations with People's Gas on our current next pilot, and they actually told us, you know, to get the rate increased that they can charge customers, they actually do have to prove how they're going to protect low and moderate income houses. So if they can actually get more people signed up to their customer assistance programs, that's good for them because then that justifies them raising the rate on everyone else and they don't lose any more money. So there are a lot of people we've talked to in the C-suite level that do care about reducing bad debt because it does affect their cost recovery. And also if they have more people signed up, they actually aren't losing any money there.
Okay, so what's the conversion though once you identify the the household? Like, how do you improve the performance of that household for the utility?
So one is getting them signed up to the customer assistance programs. That's the main way, because once a customer is indebted between $600 to $2,000, they actually just disappear from the system and they'll reappear under a different person's name because they can register with the utility under a different adult in the house. And so that bad debt actually doesn't get written off. Then the other thing is to deploy energy efficient technologies to some of these houses, right? Because that is why it's really important that we are identifying different types of risk. So here I showed pipe freeze risk for the winter, but in the summer we also can identify heat stroke risk, heat illness risk there. And so those would be, prime candidates for heat pump deployment. For example, pipe freeze risk is installation deployment. So the utilities really do want to get people signed up to those different programs, and then they're going to have less financial risk on that side. We are predicting that with our individualized marketing, we can convert people at a rate of at least 50%. Right now, the utility currently markets to these households using billboards, bus ads, and newspaper campaigns, which has a conversion rate of about 5 to 10%.
All right, thank you.
Thank you.
Could you, oh, you're doing, all right. Next up, Adena Power.
Hello, my name is Amanda Gibson. I'm a lead engineer and founding member of Adena Power. This is my first pitch, so go easy on me. We all know to achieve our climate goals that we need to evolve the energy storage grid, the energy grid, and we need to fulfill the demand from the power companies. What they want is a long duration, safe, and low cost energy storage solution, and they want to be the #1 customer, not falling behind the EV market. This is never going to happen with lithium ion, and furthermore, lithium ion is not appropriate for dense urban settings. Our mother company knows very well in Nexeris, through the development of Lion Tamer, a battery safety sensor, that lithium ion just carries too much fire and explosion risk. We solve these problems with our breakthrough solid-state sodium battery technology. Our chemistry is such that a battery fire or explosion can never occur. All of our materials are domestically sourced and earth abundant, and we use sodium instead of lithium, which is much less expensive. Our go-to-market strategy is two-phase. First is going to be launching our turnkey system for the commercial and industrial sector, and that will provide us with early revenue and product validation. We've already amassed a strong customer pipeline in our beachhead markets of EV charging and healthcare resilience. We see this as a stepping stone towards utility companies and grid-scale storage. These companies require extensive validation before they adopt any new market, but it's a huge, huge market. And we expect to be providing millions of batteries and being a major part of the green energy grid by the end of the decade. What makes our technology so attractive to our customers is that it's not new. It is a well-understood chemistry, and we have reimagined the molten salt battery and addressed the critical flaws from the past, those being a tubular design and a nickel cathode. Our years of ceramics expertise has led us to design an innovative planar electrolyte, and we've also obtained an exclusive license from the Pacific Northwest National Lab to substitute nickel with iron. Both of these drastically reduce the cost of cell manufacture. And to put our money where our mouth is, last year our team launched a building block demonstration at Ohio State University, and this year we have a larger demonstration scheduled at Duke Energy. These demonstrations are key to converting our $50 million customer pipeline into POs and generating revenue. Our team has a strong experience in turning lab-scale technologies into commercial products, and we've returned value to dozens of companies, both large and small. We've leveraged these contacts for our advisory board, and I'd like to point out Current Chemical is our partner for manufacturing. They have a lot of underutilized assets that will allow us to get through the manufacturing valley of death with a low CapEx structure. We're seeking $3 million in seed funding for these demonstrations, supplemented with non-dilutive funding. We have a really strong IP position, path to scale, and a huge profit potential, so we expect to be a very successful company. And we're looking for people to partner with us. You can definitely come talk to me after this, and you can also reach out to our co-founders, Nathan Cooley and Neil Kidner. Thank you.
Awesome first pitch. Let's give it up again for Amanda.
Thank you.
Can you tell us a little bit more about the competitive landscape across sodium-based batteries? Definitely interested in moving away from, lithium, cobalt, et cetera, but there are more competitors than you had time to show.
Right. I think we do have a, this one. We do have a short competitive market slide. For sodium specifically, I'm not sure really the other companies. I know there's a lot of sodium ion that is, I think, looking for more short duration, but there's a lot of companies like zinc-based batteries and form. So different chemistries, but kind of the similar, goal, yeah. Sorry.
Maybe can you answer it why your technology is better than all other sodium batteries?
So we have really high, excellent round-trip efficiency and energy density. Our batteries have been shown, this chemistry has been shown to have thousands of cycles for years. It's very safe. There's no possibility of an electric short. Well, if a short occurs, there's a passivation reaction that is completely harmless, and it's a lot cheaper too.
Yeah, to that point on cheaper, what's the projected cost, like dollars per kilowatt hour at scale?
I am the technical person, so,
Okay.
but I believe, I don't really know, I'm sorry.
Okay, we'll follow up on that one.
Yeah,
And
I'll
then
find
the second
out.
question is, proven chemistry, licensed technology. What has actually been built at this point?
So I actually brought a demonstration cell. This is our Gen 2 platform. We're still pre-seed, but I think we're quite advanced for being pre-seed. This is our Gen 2 platform. It was originally just a big clunky metal cell that we had to operate on a hot plate and a glove box, but we have like metal stamp components, and these can be made by the hundreds right now in our lab. But we have, some great pipelines for higher manufacturing.
Thank you. Sustainable composites.
All right. Okay, before I begin, I want you to look around. You're wearing something leather today, perhaps your shoes, your belt, carrying a leather bag, came here on leather car seats. Raise your hands if one of these is true. Okay, most of us. And this is why the leather market is a $243 billion market that is expected to almost double by 2030. But there's a problem with this market. This market is extremely inefficient. It generates about 50 to up to 85% waste, to the equivalent of about 4 billion pounds of scrap, and that's just the scrap, not post-consumer, in landfills, with an impact of about 3 billion pounds of carbon. Now, we know that this is unacceptable and unsustainable, and more awareness about waste in the market is making consumers demand more. In fact, the sustainability market is growing in double digits. And just last year, 75% more consumers were demanding sustainability from their brands than the year before. And brands want to meet this demand. But unfortunately, it's very difficult to find real alternatives that meet quality and price standards that make actual use of recycled products viable. Until now, Inspire Leather is the first competitively priced, high quality, truly circular leather, recycled leather. This patented process has been in development for many years to achieve the quality standards that will make recycled product use scale. It is the only technology that uses recycled, finished, unsorted leather scrap. Now, for those of you in circularity, you know that the magic word here is unsorted. We've heard about what's happening to plastics. We've heard about what's difficult in sorting textiles, and this is the first technology that can actually recycle leather without sorting. And what's better is that it is capital efficient and scalable, and because it uses third-party manufacturing and finishing that results in product with quality that is as close to new leather. And I have some samples here to show you. So we make sustainability possible by providing a product that is actually truly competitively priced. It is also superior in its circularity. Our products are comprised of 60% recycled leather content, and most of the products out there are 10 to 20%. It is a greener alternative because the process uses no red-listed materials, while alternatives do and use a lot of plastic to bond. And most of all, its manufacturing process uses 75% less carbon than new leather. Across sustainability attributes and physical leather attributes, we perform better, but don't take our word for it. The biggest tanneries and brands have tested our products and have been consistently judged to have the best leather qualities with enough actual leather content to be classified as leather. Our traction has been growing in the last year alone with some of the biggest brands in our pipeline. And there's so much latent demand out there that one unnamed brand is sitting on about $90 million worth of scrap in its inventory. We have two revenue streams, licensing to tanneries with the beachhead market in Asia, where about 60% of all leather manufacturing occurs, and direct sales to consumer brands in the EU and the US. In the EU, textiles were just banned in landfill, which means that legislation is on our side. We're on track to $60 million in revenue with a team that is set to do it. Our CEO, former CEO of American Eagle Outfitters, VP of Sourcing for Coach, and my background is in circularity and food waste.
Cutting you off here. All right.
Thank you.
All right.
Love it.
Yes.
Can you talk about the performance of the product, the durability, the wear? You know, I have a lot of pleather that flakes.
Yes, I'm gonna hand this to. Oh, love it. Oh. So each brand and each use has different durability and performance standards. As you can see from our pipeline, each of these brands have different demands, and we can formulate to these specs.
Can you tell us more about how you get your input material and whether that's scalable as you grow?
Yes, so working with tanneries, the scrap is already there. The brands themselves, like I said, hold their scrap. A lot of them are holding it because they can't dispose of it because that will impact their ESG numbers. There's a lot of latent scrap inventory already available. So they send the material to us, we sell it back to them.
One quick question about the unit economics. It indicated that you're charging $4 per unit versus $3 per unit for new leather, but that you're also lowering the cost of goods sold for the tanneries. I was confused by how your price point is higher, but your cost is lower. That didn't make sense to me.
Yeah, so those are average price ranges. So those would be the pricing for the direct sales to brands. Tanneries are priced differently.
All right. Thank you. All right, in case anybody didn't sign up.
investor? Here's your chance again. Sculled or schooled? Sculled or schooled?
Hello, my name is Sarah Jordan. I am co-founder and CEO of Schooled. We don't typically think of ourselves in the clean tech space. We typically think of ourselves as an advanced manufacturing and advanced materials company. So I was really pleasantly surprised to hear so much talk about metals today. If you take away anything today, I want you to know how serious the problem of metals manufacturing is. It contributes 14% of global warming emissions. It's second highest category, second only to the transportation industry. And there is a lot of work being done to try to make better refining technologies, as was mentioned earlier today. But our approach is different. We believe part of the solution is having improved metal recycling technologies. So our focus is on cleaner, more efficient manufacturing around metal casting technologies. All of our technologies are based on something called lost foam, which per the DOE is 37% more efficient than traditional casting. And traditional casting itself, because it is a recycling process, is about 95% less emissions than refining from ore. So for every ton of aluminum we can convert from that would be made from ore, we can save at least 4 tons of CO2. And that's assuming you made that CO2, that you made that aluminum with hydropower. So it's even worse if you're making it with a coal-fired plant. Our processes have an enormous market because we are competitive to a host of traditional manufacturing processes. We have a lot of traction so far, several SBIRs. We are part of Oak Ridge National Lab's Innovation Crossroads program, which is a DOE-funded LEAP program, as well as commercial orders. So currently we are scaling. This is a little bit of data. It's actually closer to $75,000 in current orders, much of which are currently waiting on us. We have a small aluminum melting facility, and we are currently expanding to a new site where we will be installing 3 induction furnaces and installing basically 6 million pounds of new casting capacity. Since announcing that that's what we are doing, we've been getting a lot of people requesting quotes. Over 12 million so far this year, and some of that they've given us forecasts going forward. So we actually expect that we will be out of capacity sometime early next year. Team shown here, we're co-founded by a team of metallurgical engineers with a lot of experience in the casting industry. We also have several sales reps and key advisors. We went through the regional I-Corps in Tennessee last year, as well as the Spark Clean Tech Accelerator. So what are we looking for? A couple things. One, we're always looking for additional customers, people who need complex metal parts. In particular, because I do have a passion around clean tech, and our vision of our company is overthrow conventional metals manufacturing and save the world. We also try to find other people in the clean tech space who need metal parts because we believe we can help them drive down their costs. We are also looking to develop relationships with potential fundraising going forward. Right now, we are looking ahead to when we do run out of capacity and thinking that we are going to need to be raising about $5 to $10 million to build either a larger plant or a second plant. And finally, I guess kind of related to the first one, we are going to be applying to the American Made Challenge for the Make It Facilities Prize, which is due here early May. So I am looking for folks who are in the hydrogen space. I am trying to do customer discovery in that area. So if you know people or you are that kind of person, reach out to me. So thank you.
Can you share more on the IP?
Yeah, so we currently have 2 patents pending around our additive manufacturing process. Basically, it's a process where we 3D print in a polymer and then use it in a process like lost foam to convert it to a metal part. We also have a lot of trade secrets around some other things related to lost foam, such as being able to do lost foam in Inconel and steel alloys.
So good to see you again. I'm on the advisory board at Oak Ridge, and saw your pitch there and thought it was pretty cool. Good to see the program is going well. You know, had less technical risks than a lot of the stuff that goes through there, but you were still working through some of the technical challenges. Can you talk about what product lines you have locked down now and ready to roll out and what you will have in the future?
Yeah, so right now, the things that we are, I guess, working on commercializing are related to this additive manufacturing approach. This is more, I guess I could say, developed in iron and aluminum alloys. That's where we've done the most development, whereas like nickel is kind of a lower TRL. We are also working on a new system so that other people can use our process, which we call the lightning metal. It's kind of TRL 5, so, but we are hoping to have that prototype finished by this summer. And then we also have a lightweighting technology related to ductile iron that we are commercializing.
And what's the basis of your competitive advantage? Is it more around quality? Is it around cost? Is it some combination?
It does depend on the product line. So with respect to the additive side, it is around both cost, speed, and quality. Metal powders are extremely expensive, and we also have an easier ability to scale because we do use much lower cost printers. All right. Well,
You framed more recycling, right, as a key piece to decarbonization here. So can you talk more about your presumably recycled or prompt scrap feedstock and the composition and challenges there with sourcing?
Yeah, so I think foundries don't typically think of themselves as clean tech, even though all of our feedstock is being recycled. Either it's secondary aluminum, and then internally we 100% recycle everything. And then when we make iron and ferrous products, we buy steel scraps, typically from stampings processes.
All right, thank you.
Thank you.
Ironworks Technologies. I'll hand them out so you can get up.
Okay, hi, I'm Valentin Solzer, co-founder and CEO of Ironworks Technologies, Inc. And Ironworks, our mission is to accelerate battery R&D using physics-based models and machine learning. So why do we need to accelerate R&D for batteries? Well, it's because companies today are spending millions, up to hundreds of millions of dollars on battery R&D, whether it's battery materials companies like Solid Power or QuantumScape, or OEMs like Volkswagen, Ford, or GM. They've all announced through various forms that they're going to be spending hundreds of millions of dollars on this problem. And the reason is that battery R&D requires a lot of experiments, and these experiments are very time-consuming, anywhere from a week to 2 years, and they cost a lot of money, something like $20 to $1,000 per each experiment. What we're doing at Ironworks is we're accelerating the R&D process by replacing some of those experiments with models instead. Our core tech stack is built on a Python platform that combines physics-based models, data analysis, and machine learning algorithms, some of which are open source, built by ourselves and by others. Plus, we've built a cloud-based graphical user interface that makes it easier for non-experts to use this software and get the same level of insights out of it. Using this software, our existing customers have already told us that they've saved millions of dollars. One company, Sealer Nanotechnologies, which is a silicon anode company in the Bay Area, said they were able to simulate 500,000 experiments, which, if they'd had to do them in the lab, would have cost them $8 million. And that's just in the first year of working with us. But it's not just the materials companies who can benefit from this. We've already demonstrated traction across the entire battery value chain. So we're working with battery materials companies. They're interested in qualifying their materials and also designing their cells. We're also working with OEMs an Indian auto OEM. We're working with Microsoft on their consumer electronics, and we're working with companies in aerospace. They're interested in predicting performance and lifetime for warranty decisions, also designing batteries to fit within the constraints of their products. And we're working with battery intelligence companies, helping them to build the right control algorithms using our physics-based models. So in total, since about this time last year, we've worked on $600,000 in contracts. Originally, we were working with a funded development model. So the first $400,000 of that was funded development with these companies. Now we've pivoted entirely to a product-based model. So the 50% that are finished are now renewed as product licenses, and we'll be renewing the next 50% as product-based licenses as well. So where are we now? We're seeking $1 million in funding to really accelerate our growth along that product journey, keeping the funded development as it is now, but really focusing a lot more on the software, both the Python platform and the cloud GUI. So we're looking for that $1 million to hire a really good software engineering team to enable that. And our projections are that we're going to grow steadily to $10 million ARR by 2028 and above that beyond. So happy to take any questions now or after. You can contact me at this email address.
Thank you for that presentation. In terms of your target market, are you looking at more established players, or you're looking at up-and-coming startups in the battery space?
It's definitely more established. So we come at the point where modeling is useful.
Right.
So you already have an existing product that you want to make better. So, our smallest customer is probably about $500 million or $1 billion in valuation. But some of those are late-stage startups. Some of those are public companies, Fortune 500, yeah.
And do you reckon that there are enough of them out there to sell the software at a high enough price point in order to scale, you think?
So we're targeting at scale about $500,000 to $1 million per customer, which is based on our licensing model, both on the power users who would be using the Python and the more regular users who would be using the cloud front end. And already there's hundreds of those kinds of companies who could use that, and the market is growing 20% every year. So yeah.
There's probably a dozen players in the market or more, competitors of yours. How do you compare against them, and how do you beat them?
So the big difference between us and our competitors is the open source software that kind of this company grew out of. So we're already kind of internationally recognized team. Once we say, we're the team that built PyBAM, all of our target customers already know who we are. So that's a huge step up in converting customers. And that's why we've been able to, in just a year, get so much traction already.
The data that's being used to simulate, is it mostly the customer's data, or are you adding incremental data?
It's customers' data. We're purely a software company.
Great. And then follow-up question from a cybersecurity perspective, what, I guess, have you had any concerns around that from your customer's perspective?
Yeah, so we have two products. One, the Python kind of goes on-premise, so there's no concerns on that side. And then the cloud side, we're going to do all of the standard compliance, the SOC 2, the ISO 21, or whatever it is, to make sure that we're at the same level as all our competitors on that front.
Great, thank you. Physics inverted materials.
Hello, I'm Emil Anblank. I'm the CEO of Physics Inverted Materials, and we are digitizing materials development. So I want to start by taking you back 150 years to when Thomas Edison developed the first electric light bulb. The story goes that he tried thousands of different filaments before he found one that was able to reliably produce electric light. Fast forward to today, and this process is known as Edisonian trial and error, where it dominates materials development, leading to decades-long materials timelines. Over the past century, you can see key materials innovations all take about 20 years to get from a first prototype to a first commercial product. And if we look at the key materials that are going to be powering the energy revolution, there will be, beholden to the same process. But trial and error isn't used in all industries. Other industries greatly benefit from digital design. For example, in the electronics industry, we have electronic design automation, which facilitates designing billion transistor chips. Or in product design, we have computer-aided design that allows you to build million component parts. The material space is different. We have trillions of atoms that compose all of our materials, and you have to then segment out materials design into its different length scales. Taking just one length scale, the atomic scale, for instance, we have a couple models that allow you to do some digital design, but they're all beholden to an accuracy-cost trade-off, where some models are good in cost and others are good in accuracy, but there's no models that allow you to do digital design, and therefore you're beholden to this trial and error with experimentation. What physics inverted materials is doing is developing machine learning models that allows you to have great performance across the accuracy-cost trade-off to be able to develop materials models and be able to digitally design materials. We're deploying this as a cloud interface, which allows our customers to upload material they're interested in, a specific simulation protocol that gives you a materials property, and then our back end develops those machine learning models and then provides those material properties to our customers to use. We have a short demonstration here of our software in action. So you start by uploading a structure. Here the demonstration is for water. You can visualize it, look at it, and then what you do is then set up a specific simulation that you want to run. Let's say you want the density or viscosity of your next battery electrolyte and test it before you actually go and fabricate it. You can run that, have the task be simulated in the cloud, and then download that data to make the decision on if you want to pursue that new electrolyte before you even start it. And so physics inverted materials is aiming to be the digital materials design solution for the 21st century, where our digital models allows customers to simulate, prototype, and design materials from discovery to prototyping and all the way through manufacturing. So that I want to thank you and welcome any questions.
How do you benchmark the accuracy of your model?
Yeah, so there's two ways. There's against other computational models. So like I was saying, there's the kind of accuracy cost trade-off. And so there's very accurate models that people have shown to be accurate. We can benchmark our models against those and show that we're just as accurate, but at a very competitive price point. So for instance, we have 3 nines of accuracy against an accurate model, but then 10,000 times lower cost. So that's one way that we benchmark the accuracy and cost. And then the other is performance against experiments. So actually, does this reproduce a real world type of example? And so we can do those simulations and then show that we're able to reproduce the experiments within kind of known bounds.
Great presentation. Mind talking us through the team and the stage that y'all are at today?
Yeah, so we're a pre-seed company. It's me and a co-founder we met at CMU, coming out of kind of PhD programs. We're in kind of the first prototype stage of our company and are closing our first customer, within the week pretty much.
So similar platforms have been developed in other spaces. There's been a bunch of attempts at this in materials. It's great to see it continue to advance. One of the things that has been learned in the last couple of decades of work on this sort of thing is sometimes you can do a lot better by just owning the technology and making your own materials versus licensing the technology. So have you thought through what your potential market size is with different business models?
Yeah, so we've definitely heard this a lot. We think that the kind of horizontal play, The horizontal play is best suited for once you actually have these foundation models. And so you can have kind of a narrow product offering that you can then kind of capture value in that one space. But we're starting and focusing on battery materials to begin with. But these high accuracy solutions are already kind of being leveraged in, or high accuracy but high cost as well, being leveraged across energy materials, semiconductors, the chemicals industry. And so these represent about $100 billion of annual materials development expenditures. And so we think we can capture about 10 billion of that by transforming to kind of a digital design platform, similar to how it's done in the electronics industry or product design industry. Yeah.
So, as mentioned, applying a digital solution is not a new approach. So, what is the levers that you're pulling that are differentiated?
Sorry, I missed kind of the.
What is the levers you're pulling that are differentiated? What are you doing different?
Yeah, so the real difference that's happened over the past 5 years, I want to first acknowledge, multi-scale materials modeling has been kind of a vision in the field since the 60s, right? It's definitely not a new, am I even speaking into the microphone? It's not a new concept. Sorry if you haven't heard me at all. It's not a new concept at all. What's really changed over the past 5 years is these machine learning models that have been shown to be performant and generalizability across a rich design space. And so, our proprietary self-learning algorithm can learn from a very small amount of high accuracy simulations and then perform well across, a number of different queries that you ask it. And then we can learn iteratively as we grow. And so
That makes sense, but what did you figure out that no one else has that makes your model better?
Yeah, so it's really the self-learning algorithm. And so we're able to learn on the fly. Going back to kind of our, what we do on the back end is we have this proprietary algorithm that nobody else has really been able to figure out that allows us to incrementally add only the most information-rich data so we can decrease our costs by still giving the most accurate machine learning model.
INSEP TV. They're gonna go. Exciting companies. Hope we left you all to.
All right. Hi, I'm Matt. I'm the CEO of INSEP TV, and we work on building a software that helps with transforming fleets from gas to electric through optimizing their planning, their overall operations, and then their routing. So I think we've learned over the past couple of days just how big of a push there is to get decarbonization across the transportation industry. But what does it look like when these vehicles are actually put in place? I spoke to a California fleet that started putting in F-150 Lightnings that looked at 300-mile ranges, but when they upfit it and actually use it in their real purpose, they're seeing 90 miles of actual range. This is a big issue, and it's causing a lot of fleets to kind of restrict their EVs to only go about 60% of the range. Not just because of how they're using it, but also due to concerns with weather restrictions such as cold weather, and also how it is they're really going to be using it and what does that differentiate from the manufacturer specifications that they're getting. On top of that, there's also just an unnecessary amount of infrastructure that they're putting in, where a Rocky Mountain Institute report actually shows that it could go up to a 4x additional cost due to not really knowing that you may not actually need one charger to one vehicle. So we get around this by using our simulation technology to take their individual use cases and then understand what it means to go from gas to electric and de-risk it before they even make their first purchase. We can then take those same vehicle parameters and look at it from a managing perspective once those vehicles have been onboarded and within the fleet, and then maximize the operations through the routing, adjust the routes as needed for weather conditions, and make sure that they're not leaving stranded vehicles across the area. We do this by taking that individual telematics data, which most companies have, especially within the fleet, specifying our models to those vehicles, and then seeing what it looks like from a simulation perspective. This takes seconds rather than potentially months of experimenting and a lot of cost that comes with using the real assets compared to our simulation models. Of course, there's a lot of use cases throughout the market between the utilities, different fleet softwares, and different fleet managers, but we have highlighted the software and service providers that we believe are the good target beachhead market for our company. And just to give you what that looks like, there's two different people that we've seen that really can make use of this. The first are what we see emerging, which is the fleet as a service space, where they kind of take on all the hardware and infrastructure risk. and then lease these vehicles to these companies to then use within their own operations. The other aspect is kind of these legacy telematics or fleet management software teams, which will take on the new electric vehicles and have to be brought up to speed with these new vehicles that are being brought into the market. And so what we offer is essentially a two-pronged solution where we first help with the planning stages, and we're expecting to charge about $100 per vehicle in that case, where we can go look through and really see what it is that their use cases are doing and how it is that we can best make sure that they're picking the right vehicles and also the right charging infrastructure. Once the planning has been done, we can then go through and then do onboard subscriptions for the management piece and again, make sure that these vehicles are being brought to speed with the different charging conditions that they have, the different weather conditions that they're experiencing, and how it is that they're going about from their day-to-day operations. So this year, we are hoping to kind of start with our first few pilot projects. We actually have a validation study that's going through the University of Michigan, seeing how our software performs against a Ford Mach-E that's being driven around the campus. And we're hoping to then expand out with more and more customers through those two different verticals that I mentioned with the different software perspectives, and then grow throughout the next couple of years. We've been through many different programs, especially some in the area, and also different stuff through both the National I-Corps, Alpha Lab. We've also were part of the Detroit Auto Show this past year. And currently the team is myself and my former PI, who's now also working at University of Michigan. And we're hoping that we can expand the team to bring in more expertise over the next year as well. And with that, I hope there's any questions I can answer.
I know we sort of sound like a broken record over here, but what's your comparative advantage? A lot of folks could do this if they aren't already, including some of your customers could in-house this type of thing. So yeah, how do you think about your comparative advantage?
Yeah, so the first thing that we have is we have a suite of patents that protect the methodology that we're doing. So there's 3 patents that we've gathered over the past year and a half. The next major thing is that the solution that we've done, which is patented, actually allows us to look at each individual vehicle and then do the different simulations. And so we have a parameter database that is completely trade secret, so to speak, that allows us to get those accurate simulations to the, in the case of what we did with the Tesla Semi, we were actually able to get it within about 5% of the SoC trace. So it's both the IP that we've secured and the parameter database that we've accumulated.
I just realized we talked over 2 years ago, so great to see you again. I'm curious what's happened since we initially chatted. Have you had any customers and paid engagement so far?
Yeah, so as I mentioned during the talk, we've started a validation study at Michigan, so that's going to be a good look at how it is that our software performs relative to actual vehicles that are operating. So that study is kind of just in the early stages right now, and we're actually going through the process of parameterizing our model to the Ford Mach-E that they're driving. And so we're hoping that once that's done, we're going to actually start the inverse problem where we're going to say, okay, this is what the vehicle is going to do. How does the simulation predict? And what does the performance actually look like? So with that, we're then hoping to garner a couple more customers, because that's kind of the main thing that a lot of people are asking is like, how does the simulation really perform? And we've been able to show it with the Tesla Drive, as I mentioned, that it's really accurate, but people want to see more data. So that's the next step there. And we've also been a part of many different programs, such as the Clean Tech Open. So continue to progress the business side, but also trying to bring in more validation studies as well.
Thank you.
Thank you.
So I'm going to take a slight break here. Our panel of investors up here has been working hard, taking notes and so on. I don't know if they've had a chance to go in and sign up for some slots. We're going to take a minute here, go in and fill in some slots. The rest of you investors, fill in your time cards. We want to see these meetings happen. So, twiddle my thumbs. Fill out some spreadsheets. One-on-one meetings are going to be in a different room. Yeah, the one-on-one meetings for the benefit of the companies and the investors are going to be in the Danforth room. Get to the Danforth room, you go out here, turn left, go down to the next large corridor, turn left, go all the way to the end of that corridor. You go like through a cafe area, you're like, I must be lost, you're not lost. Keep going all the way to the end of the corridor, and the Danforth room is at the end of that corridor. So Out of here left, left, all the way to the end, past through the cafe area. All right, and each company will have an assigned table, and everybody will be able to see the scheduled slots. All right, is everybody up here signed up for what they wanted to see so far? We're ready to get back on to the show. We're halfway through. Right, okay. Next up is, which tech? Octet Scientific, up next. Octet. Let's do it.
Hello, everyone. I'm Onis Bolton, founder and CEO of Octet Scientific, here to tell you how we're making the secret ingredients in tomorrow's best batteries. You've heard a few people say it, but the grid stationary storage markets are big and expected to grow substantially. And like a lot of the people you've heard mentioned earlier, we don't think lithium is going to be able to solve all the problems there. There's supply chain problems, there's safety problems, and then there's use case problems too, because the grid needs big, safe, reliable, long-lasting power, and lithium-ion really hasn't been designed for that. We think that the real winner, and it's something you've seen already here today, will be zinc-based batteries. Zinc batteries have been around as long as batteries have existed. The very first batteries ever invented were the voltaic pile, which was copper and zinc. If you've ever seen a AA battery, you've seen a zinc battery before, so they're not some sort of exotic kind of new future technology. Zinc batteries are always water-based, so they're non-flammable. They have high power density, some cases higher than lithium-ion. They can have very, very high energy density as well. Zinc is very abundant. We have the world's largest zinc mine here in the US. It's highly recyclable, a lot of it coming from the steel industry, so also kind of hits close to home. What we're doing is bringing new electrolyte additives that help make these batteries more competitive with lithium-ion today. So we have a product called Octolite, which is essentially specialty organic chemicals that work in the electrolyte of these batteries to help solve problems associated with dendrite growth, hydrogen, shape change, technical things that have limited zinc batteries historically to basically keeping them in the non-rechargeable space. What we're doing is bringing a new suite of chemicals, and we're a chemical supplier, that can really supercharge these batteries with a really small add. Octolite, as I said, it's an organic chemical. It's water-based. Usually looks like a white powder, so it's not the coolest thing in the world to look at, but it gets blended into the battery and it can add a lot of performance. You see these numbers down below, and a lot of these are taken from customer data, so we can increase the capacity by 25%. If you can plate more zinc in the battery, you can store more energy in the battery, you can increase the capacity just by adding a few percent of our product into the electrolyte. We can extend the cycle life sometimes up to 300%. If you don't have dendrites that short the batteries in some cases, in many cases, you can extend the life of the battery. And we can also lower the operating cost by reducing hydrogen. So all these things together bring a really, really big value package to these zinc batteries in a very, very small, well, a big amount of value in a small package. Some numbers on the side there from Pacific Northwest National Lab. These are approximate installed cost per kilowatt hour for different competing technologies on the grid. Lithium-ion LFP is one people are talking about a lot. Today's zinc technologies, which is quite broad and encompasses many different types of zinc, is quite competitive, and with the lifetime improvements and with the CapEx improvements from capacity, we can make zinc much more competitive than even today's lithium LFP. The grid market's going to be big. You've heard this already. The big challenge for us is how much of that can zinc capture? And based on many of our customers and future customers' numbers, we think that zinc could capture 10% of that in the next 10 years. And as I mentioned before, our products bring a lot of value, a very outsized amount of value to these batteries for their size. So we think they could be a very valuable part of this overall ecosystem supply chain around zinc batteries. We're the first ones to really identify that zinc batteries were missing this in their supply chain. We also are working with alkaline companies, so I'm proud to say that as we speak, there are 3,000 alkaline cells being built right now with Octet products in them in a pilot plant at a $3 billion customer in North America. It's a market most people don't think of, but it's huge and continuing to grow. Our financial forecasts basically follow the opportunities of the grid, so we're engaging with a number of customers. We're staying lean. We're using third-party manufacturing to produce our materials without having to build our own facility. So once we spec in, once we get through pilot, then we're basically along with the ride for some of the grid companies we're working with. We're raising a $5 million seed round right now. We've got a strategic lead who's bringing about half of that so far, and we've done a lot with grant funding. I've got 5 seconds, so I'm trying to go really quick. Yeah, that's it. Thank you. This goes fast.
Can you clarify the use cases here? Because I saw different kinds of batteries being shown.
Yeah. We're basically working with anybody who's doing a zinc-based chemistry, and it involves a number of verticals. Grid storage is the big exciting one, but amongst that, there's zinc flow, there's static zinc, there's acidic zinc, alkaline, and we have kind of tailor-made solutions for different people working in that space. There's also the stationary power, think like backup batteries. We're working with companies who are trying to displace lead acid for data centers and things like that, and hopefully eventually someday lithium or lead acid that's in cars. And then there's like the alkaline ones too. So that's one of our challenges, to develop products for all these different kinds of verticals. But thankfully, what do they all do? They're all in water, they're all plating zinc. Some have different pHs, but we have a suite of chemicals, 6 patents now on different materials to address the different needs.
So if we take your chemistry, you're showing a 25% reduction. I assume that that is kind of 20, if it was $100, you would get to 75. Is that right? Because it's always...
Yeah, that's the simple math we've used here. If you're adding capacity to the battery, you're making each battery into more battery. You know, they're selling energy storage, not batteries, so that's...
That makes sense. No, I appreciate that. And so then you know, for dendrites, for example, what technology are you using that allows you to cause that not to happen? Because it's a fundamental problem in all batteries that no one can solve.
Yeah. Well, for zinc, I founded this company after coming from the electroplating industry. And so we've developed suites of products that can selectively stop the growth of dendrite nuclei without hindering the smooth, so to speak, zinc deposition. You know, a lot of it's just electroplating, and I used to work for Adotech. So there are organic molecules that have special preferences to dendrite nuclei that you know, stop them from happening without hurting the rest of the overall performance in the battery. And we found that a number of customers, there are some who like dendrites, there are some who like different kinds of high surface area growth that we're working with. And so for them, well, we have over 300 different molecules we've designed and synthesized that we can test. We found some that do a variety of things, and there's really no one else addressing this need in this, you know, high potential emerging market.
All right, thank you.
Thanks.
Okay, so hi, my name is Ray. I'm the co-founder of NovoLink and Innovation Commercialization Fellow of SWOT Center CMU. So at the high level, NovoLink developed a revolutionary composite nanostructured film that can resolve the bottleneck challenge of heat dissipations in all kinds of energy-dense devices and systems, like your laptops or the data centers. Through our customer discovery, currently, data center is regarded as our beachhead market. So as everybody knows, especially in the past several years, with the fast development of AI, we need more computation power than ever, right? So that further push the fast development of data center market to grow at over 20% rate annually. As many people may have not noticed, that data center consumes more electricity than an entire country. Like numerically, data center consumes 1 to 1.3% electricity globally every year, while 40% of that is consumed by data center cooling. So therefore, the pressure to make data centers sustainable is high. In modern data centers, no matter in the air-cooled or hybrid-cooled or liquid-cooled, or even the up-to-date immersion cooling-based technologies, thermal interface barrier is always an inevitable barrier that you must overcome to efficiently dissipate the heat generated from chip to the surrounding environment. Especially with the fast development of the immersion cooling technology, the interface resistance is becoming more critical and even the bottleneck challenge for data center cooling. However, the existing technologies, for example, the thermal pads or thermal pastes commonly used, can no longer fulfill the needs of advanced data centers because of their poor thermal performance and low reliability. That's why the field is currently intensively looking for next generation technologies that can really boost up the cooling performance of data centers. NovaLink presents you a composite nanostructured film that has 10 to 100 times better performance as compared to the traditional materials. Even comparing with the best thermal interface materials in the market, for example, the Honeywell phase change pad or the thermal grease, our product is still 5 times better in the performance. It is tested under the ASTM standard test platform. Also, we are at a comparable cost. So through the implication of our material in the data centers all over the world can save up to $1 billion US in electricity consumption for the operation of data centers. It is equivalent to 4.5 million tons of carbon dioxide emission. Or if we think it from another aspect, to realize the same amount of computation power, we can build 8% less data centers by using our material because we better cool the chips and the chips can be stressed to work more efficiently. Our team has more than 10 years deep dive in the thermal interface material field. Our research is supported by over 4 million federal grants from DARPA, NSF, and DOE. And it is also worth mentioning that we are one of the 15 teams that awarded the prestigious ARPA-E Cooler Chips program, specifically for data center cooling. And that's where we team up with Meta and other leading experts in the US. So we are currently actively looking for industrial partners and pre-seed funds. By the way, we have five pending patents and licensed. So to finish, AI is transforming the future of human beings, and NovaLink is founding a sustainable future of AI. Thank you.
Really cool work.
Thanks.
Can you tell us how you envision this material being manufactured at scale and put onto the equipment?
Sure. Currently in the lab, we have realized the printing-based, pure solution process printing-based, low-cost manufacturing. We can realize this scale by simple printing. And it's not really limited by our facility. It's limited by the raw materials we can purchase. Also, we are developing even larger scale by roll-to-roll printing. So we have the prototype ready in the lab.
Right. Thank you for the presentation. Looks like a pretty interesting technology you've got here. In terms of what it does, I guess it goes beneath the chip and helps with the cooling. And that space in general is very disaggregated in terms of chip making. How do you gain the distribution to really sell to the folks that are making chips, or are you perhaps thinking of partnering and licensing to established players like the ones you showed?
Okay, so we are not really directly selling our material to the chip manufacturers because in the thermal interface material field, there are 3 categories, including thermal interface material 1, that's for the chip packaging. 1.5 is for the direct die to cold pad connection. That's for typical data centers, that's where we target. The third one is the Team 2, that's used for your cell phones or laptops to connect the chip to the heat sink. So for us, we are manufacturing our materials, not licensing. We're trying to do more industrial validations with the data center device providers. Then after validation, we build our customer connections. Also, further, we will look into the 3C products market or even the hard drives or other heat accumulation areas.
All right, thank you.
Thank you.
Green Swans.
Hi, my name is Chetan Chathani. I'm the founder and CEO of Safely and Green Swans. I'm a serial entrepreneur right here from Pittsburgh, built and sold a couple companies here along with my co-founders. The technology is around making lithium batteries fire safe. Before I start, a big shout out to all the battery technologies and chemistries out there. We're gonna need them all. The coming energy transition is gonna require all kinds of storage technologies, and there's a place for everybody. I don't need to spend any time on this. We all know about the challenge with fires with lithium-ion batteries and the reasons for that. Short, leading to thermal runaway, leading to fires, leading to explosions. We're not the first people to look at solving fire safety in lithium-ion batteries. A lot of people have been working on this for a very long time. These batteries have been around for a very long time. People are currently looking at solutions such as battery management systems, trying to figure out when to charge, looking at the conditions of charging, potentially finding the specific cells that have a problem and kind of isolating this and so on. Some people are using cooling systems, external cooling systems like glycol cooling, just to make sure you don't get thermal runaway. Others have used heat-resistant coating, gapping. So lots of things have been tried. Interestingly enough, a top 5 battery manufacturer globally made the comment to us when we met with them about 1.5 years ago that the industry has essentially given up trying to solve lithium-ion battery safety at the core chemistry, the core design level, because a lot of things have been tried and nothing has worked. So that was a very interesting comment from them. Ceramics or ceramic separators is something that a lot of people have looked into, particularly standalone ceramic separators. A couple challenges with standalone ceramic separators is ceramics are hard but brittle, so you don't have structural integrity, so that's a challenge. And the other challenge with separators in general is the wettability. How well can they wet with electrolyte? So our solution is a specifically designed material, which is in a family of materials called zeolites, which is essentially alumina silicates. This material is designed to be highly porous, and it can be applied using a blade coating methodology. Couple things that our material does because of the morphology of the crystals that we create in this material. Number one, we apply this material to the electrode. So essentially, we are deriving our structural integrity from the electrode itself. So we have a flexible coating on the electrode. So the electrode has structural integrity, so does our coating. So we solve the structural integrity problem by making a electrode-supported separator. The second thing is our material, due to its unique design, has a very low contact angle, meaning very, very high wettability. So when you compare this to traditional polypropylene separators, where you might see as high as 50, 60, 70-degree contact angles, we get a contact angle of about 25 degrees. This can enable a lot of things, some of the things that we haven't even explored yet, such as expanding the charging range, from 0 to 40 to as much as, minus 15 to 65 degrees Celsius. There's things that we haven't even explored in terms of what our chemistry can actually do. But those are some of the things enabled by these structural properties of our technology. The technology comes out of Arizona State University. When we licensed it from ASU, the technology was proven at a coin cell level. And we are about 3/4 of our way towards a pre-A battery. So we successfully completed phase 1 of a game changer project under the Shell Game Changer program, and we successfully demonstrated a single-layer pouch cell. We are now moving towards a multi-layer 1 amp-hour pre-A battery. We currently have a 4-layer technology that has been tested and just moving down that path. I see that I'm almost out of time. We have done some safety testing. This is an important one, nail penetration. Traditional battery failed within a minute. Our battery continued working with a nail through it with no change in the performance. What are we looking for? We're doing a capital raise, a seed round of about $5 million to set up a lab right here in Pittsburgh. And we're also looking for introduction to battery manufacturers. Our approach to the marketplace is to work with existing battery manufacturers and become a small part of their manufacturing process. Thank you, and I'm happy to take any questions.
How does your separator material integrate into today's lithium-ion battery manufacturing processes?
Right, so currently the way battery manufacturing is done, the battery manufacturer would typically have coating lines to coat their electrodes, and then they have assembly lines where you have electrodes, separators, all put into a pouch, and then you put the electrolyte. We would add a step in the coating process where you first coat the electrode, then you coat our separator on the electrode. You don't need the separator anymore, and then you just assemble and fill in the electrolyte. So it's a one additional step in the process and removal of one material in the process.
Mind talking about the use of funds for the $5 million and why are you moving here? What do you use with that? Do with that money?
So we are a Pittsburgh company. So we want to open the lab here in Pittsburgh. The $5 million will be used to set up a battery lab so we can do a lot of the manufacturing of the early stage batteries ourselves, and then hiring some additional resources. Once we have that set up, we'll also be working with outside battery manufacturers to get to the pilot scale where we can now do some level of pilot scale manufacturing.
What was the time to commercialization?
We believe we'll have a pre-A sample by June. Once we have the pre-A sample, which is 1 amp hour, I think because we are only changing one step in the process, within 1 year, we should have small capacity batteries in the market. And then beyond that, another year to get to the higher capacity batteries. So fairly quick, I would say.
Okay, thank you.
Thank you.
Power 3D. Slots.
Afternoon, I'm Justin Payne, CTO of Power 3D. Okay. We're working on 3D printed porous electrode structures to increase battery energy density. So we found our problem market fit after participating in NSF Core and interviewing over 100 potential customers in the unmanned aerial vehicle space. The application of our technology to drones will increase the mission time as well as increase range, which will save a traditional operator greater than $100,000 in annual costs, operating costs, along with enabling them to address a broader range of markets than they currently are able to. How we do that is a patented 3D printed electrode structure. Shown here is an example of a cathode structure that through our proof of concept coin cell testing gives between 50 and 100% longer battery life. Now by life, in this case, I mean capacity or energy density. We have modeling and simulation that indicates we'll be able to scale to 80% faster charging rates with a 40% longer total cycle life than a traditional lithium-ion battery. Sort of mentioned previously, drones, our value proposition just aligns well with them. That industry, they are a bit less cost sensitive because they tend to be business to business. And they give us the opportunity to gain revenue and get relatively rapid growth. They are a $5.2 billion at this point segment. So if you call 5.2 a niche in a $220 billion segment, that by getting a beachhead there enables us to have revenue growth and then also reinvest in scaling our technology and reaching out into larger market segments in the battery space. It's best to focus on the purple illustration in the center of the slide to briefly articulate the fundamentals of our technology. On the left is a traditional solid electrode structure, and on the right is a schematic of our 3D printed lattice. Our technology enables higher utilization of active electrode material, be it cathode or anode, in order to increase battery capacity. The team is comprised of our CEO, Peter Scott. He's a 3-time startup founder, has raised more than $12 million in his career, and Dr. Rahul Panat. He's the inventor of the original technology for the 3D printing and a professor of mechanical engineering here at Carnegie Mellon. And myself, materials scientist with over 20 years of experience in process development for the semiconductor industry, also a 2-time startup founder. We are seeking a $600,000 seed round to scale our proof of concept into a prototype to realize our goals of proving 50% higher energy density and 80% faster charge rates. Thank you for your time. I'm happy to answer any questions.
Okay, maybe a dumb question. Is the lattice structure itself also active material, or are you putting active material into the pores?
Okay, so the lattice structure is the active material. I can go into some explanation of how it works if you want, but we saturate that with electrolyte. So you're shortening the path length for lithium-ion migration, basically.
And so 3D structured electrodes have been a thing for a while. I mean, a lot of firms have tried doing variations on this. What's different this time? How are you doing it different than what's come before?
So throwing it out there, if you're mentioning like Amprius, right? That's a specifically anode play, and they do remarkable work, obviously, with the enabling silicon technologies. So what we're doing is optimizing basically diffusion lengths and path lengths for lithium intercalation, right? So we're starting with the cathode side, and so we're printing like LFP, some tests currently with LCO, and we're able to control dimensions across a range from single-digit microns to, say, 200 microns within this lattice to manipulate the parameters. I mean, so it's a very structured porous electrode. It's not just, yeah. I'll stop there.
I'll just ask another one then. What's the impact on cost? So I understand why this would have all sorts of performance benefits, but there's reasons additive manufacturing is challenging to do at scale.
You are correct. So, so in a very general sense, part of what we will need to do as we scale is to focus on the 3D printing equipment. So, I mean, simple variables, print speed. Absolutely, we have evaluations underway to understand how we can effectively increase that by, say, an order of magnitude. But then the other kind of simpler solution is to work with the vendor to have multi-head tools. Now, with that said, you'll note, if you caught it, I'm kind of new at this, unfortunately, despite my age. We are working intentionally with a less cost-sensitive initial target market to give us time to learn on that and iterate and see where we can drive it to. It may very well be true that there will be certain specific attacks in niches in order to tolerate a final floor on cost, but we don't see it as a big barrier currently.
You're targeting 80% faster charge. Where are you towards that goal?
I'm sorry, could you repeat, please?
You're targeting an 80% faster charge, right? Where are you towards that goal?
Well, okay, so the answer is from, we don't have proof of the longer cycle life at that charge rate, but we have proven in the proof of concept coin cell, this is very early work, that it's achievable. Oh boy. I don't really have a better answer than that. But basically, what we're able to observe on a battery tester mimics the model relatively closely. That's kind of all I can comment at the present.
All right, thank you.
Okay.
All right, investors up here want to sign up for any more in a second? Next up is Core Power Magnetics.
All right. Hi, everyone. I'm Sam Kearney, and I'm the CEO of Core Power Magnetics. Thank you for having me here today. And I think when I submitted this, I thought it was an 8-minute talk, so buckle up. All right. So here at Core Power Magnetics, we are driving magnetification forward. So when you think about magnetification, thinking about things like electrification, there's been a huge improvement in aspects like battery technology, semiconductor technology, and really the bottleneck that's remaining that's holding back electrical systems like EVs and just the grid overall. All electrons that are generated have to go through magnetics at some point. The bottleneck is now those magnetics. And so you see just a huge amount in the EVs, and it's really holding back things like range and charging speed in these vehicles, things like distribution transformer shortages that we're seeing right now too. So this is where core power magnetics comes in. We are reducing the size and weight of these components, improving the efficiency, and in the case of our motor products, we're eliminating the need for rare earth elements. We're doing this with a combination of advanced materials, processes, and component design. So you see the components up here, that's what we're selling to the customer. On the technology side, you can really break it down into a couple key areas. The first is that we're increasing the operating frequency. That helps us to reduce the size. The second is that we've developed the material chemistries to be able to operate at much higher temperatures, so they're no longer the weak link in that thermal chain. And then we have an advanced process that allows us to control how each section of the metal ribbon magnetizes so that we can prevent hot spots from forming in the first place. So what does this mean in practice? In a motor application with this drive cycle comparison, we can reduce the motor size by about half and increase the efficiency by cutting losses by around 80%. This means we can improve the overall range of the vehicle substantially, or the vehicle designer can look at taking out battery capacity, which saves on cost. So I've talked a lot about EVs so far, but again, the grid is a huge opportunity for us as well, especially with EV charging. Inductors and transformers are our first products. Go-to-market strategy is focused on those because they have a higher technology readiness level. We have active customers. They're also stationary parts, so the qualification cycle is shorter. Motors, though, is the big market here, and we see the inductors and transformers being leverageable to automotive or automotive adjacent markets. With the motors in general, though, we're targeting more of the, not the passenger vehicle space first, but large vehicles and also ultralight vehicles as well. All right, the team bringing this to market is full of industry, technology, and commercialization expertise. We're excited about what we're doing because we've been successful at getting advanced products into difficult markets in the past. So our traction to date, we have over 1.5 million in revenue, and keep in mind this is all coming out of a facility that's about 1,200 square feet right now. We're excited because we have a substantial amount of non-dilutive funding that has come in or is coming in soon. So the first was an ARPA-E grant that came in 2022, along with a convertible note round that's enabling us to put in our first manufacturing facility, and that's coming online here in the next couple of months. That'll get us to the thousands of component level and really give us that credibility with the market in terms of being able to produce quality components at scale. We've been recently selected for a $20 million grant from the DOE, and so now we're raising a $25 million round. A large portion of that, the $20 million, is a one-to-one match with that grant that's enabling us to put in a large-scale casting facility, and the additional $5 million is really focused on motors. So at this facility, we're putting in a 10,000 metric ton casting line, which is very similar to the one here that's at NASA. Let's see if this plays. There we go. So what you're seeing here is molten metal coming onto a water-chilled copper wheel, cooling at 1,000,000 degrees per second. That's about 10 pounds of metal, and it makes about a mile of ribbon. It eliminates a tremendous number of processing steps in the steel manufacturing process, or embedded carbon is also a lot lower. So overall, really excited about what we're doing here. Have a great growth trajectory, both with EVs and stationary applications. You can see the timeline here. We're doing all this in the Pittsburgh area, so not only a great CMU success story, but also excited to continue building and growing here. Thank you.
Right on time, even though you said I ended the presentation.
Nice to see you again.
Yeah, you too, Jason.
You just showed that you're getting 20 or 25 million. You're going to raise 20 million. Why aren't you getting revenue until 2027?
I think we do have substantial revenue there. The large facility, so if I go back to the slide here, I think it's just more the y-axis, but like in the 2026 timeframe, we're about 30 million.
Oh, okay.
Yeah, yep.
Okay.
Yeah.
Good hockey.
You mentioned you're working with OEMs. Can you share a bit more on that, and is there potential to increase collaboration with them?
Sure, yeah, obviously we have a lot of NDAs, but we are working with large-scale manufacturers on standard products. And so we have a lot of tools that can help us to design components, but we're about finding those ones that can be applied broadly. And so the two that we have up there, Eaton and John Deere, are part of the ARPA-E program, but good examples of the type of folks that we're working with.
How have you proved out the durability of your technology?
Yeah, we just got some great test results back from a customer recently, thermal testing to validate that the overall temperature rise is coming in as expected. These are for military applications too, so there's a lot of different mil specs and testing that's going on in that direction. But yeah, to your point, there are longer qualification times for things like passenger vehicle type applications, which is why we're both aggressively pursuing, but also recognizing that revenue may not be coming in quite as soon as the transformers and inductors.
What's the breakdown of that 1.5 in revenue you currently have, and how does that change going into this year?
Sure, yeah, so the 1.5 is more focused on standard product development, so we've been getting paid by customers to come up with the products while still maintaining our IP. That starts to shift more towards the standard products, with around 2026 being where we see it really start to increase more into the tens of millions, starting with actually selling amorphous ribbon into this distribution transformer market, and some of the transformers and inductors going into things like EV charging.
Thank you.
Thank you.
Switched source.
All right, good afternoon, everybody. I'm Charlie Murray. I'm the president and co-founder of SwitchSource. Here at SwitchSource, what we're doing is we're developing the next generation of automation equipment for electric distribution utilities. We're helping them tackle challenges associated with reliability and resiliency of the electrical grid, being able to accommodate more electric vehicles, and being able to accommodate more distributed generation. All of this really boils down to is capacity, is how can utilities squeeze more capacity as efficiently as possible out of their existing wires infrastructure. And what we're taking advantage of today is sort of the natural topology of the electrical grid, which is there's this three-phase backbone. Utilities use three wires for their biggest customers, large commercial, industrial type customers. But the majority of customers by number are single-phase customers, residential, small commercial. And so what they did is they've come up with this concept of having single-phase laterals to feed groups of single-phase customers at a time as a cost-efficient way to get power to them. But what this does is it causes congestion on that three-phase backbone. And so there's a lot of capacity there that can be tapped if you have the right types of tools for it. And we are uniquely positioned with one of the only tools that can actually tap this power by intelligently routing power from phase to phase on these distribution circuits at the medium voltage level that utilities use for distributing power, which is really hard, which is where our IP is. We've recently published some papers, some results with Florida Power and Light and Seagray, kind of giving a sense to like, how big is this? So something on the order of 500 kW up to a couple of megs. Nameplate for a distribution circuit's about 10 megawatts. So if you're looking at this, you can do the math pretty quickly, the number of fast charging stations or the number of homes with residential solar that you can put on the grid without destabilizing the system when you have an extra 10% of capacity and headroom. Most of the distribution circuits out there today, somewhere running between like 80 to 90%, haven't seen real significant uptick in load growth since the adoption of electric air conditioning. All right. So the sort of number of circuits that we're applicable to, the way that we find distribution circuits that are a good fit for us are using the same criteria that distribution planners use to determine where they have imbalance issues out on the system. When we do these surveys and studies with them, we find about 25 to 50% of their circuits are a pretty good fit for us. So it's not necessarily every single circuit right out of the gate, but it's a large enough subset. We have equipment running in the field with a number of different utilities, having great luck in terms of finding good demonstration project partners that have lots of circuits that could be addressed with this type of issue, lots of different use cases that they're trying to resolve with it though. One of the biggest use cases that we're going after is reliability and resiliency. And so if you talk to a distribution utility that's cognizant of how am I going to reconfigure the grid after there's an outage, most of them are thinking about the capacity that they have on that line to bring on customers that are experiencing an outage in terms of what the peak phase is. So again, this issue is that they have one phase that might be heavily loaded compared to what the average is of those three phases. And so if you can bring that peak down, you're basically unlocking headroom for them to be able to take a group of customers that are experiencing an outage and power them with that distribution circuit without overloading it. All right, the other benefit of the device is really future-proofing the grid. So being able to accommodate more electric vehicles, being able to accommodate more distributed generation. These are use cases that we're seeing as more of like a future-proofing, like a sort of cherry on top in terms of the value proposition when we're talking to distribution utilities. It's something that the executives are thinking more about as they have a vision of what's going to happen in the next 5 to 10 years. On the right-hand side here, we have some data. Essentially just wanted to show that, after the phase EQ, which is like the right half, you'll see the sort of volatility go down. When you're able to put a device like ours on the grid, you can actually use the other two phases almost like a shock absorber for any volatility that's happening on your distribution line. And then just to give you guys a sort of idea of like sense of size of prize, this is what a rollout can look like with a given utility. So just a single utility can deploy something on the order of, $50, $100, $150 million worth of capital in a programmatic rollout of our technology. And that's it. I'll just say we're interested in meeting with any utilities that might be in the audience, as well as any investors who have networks with utilities or have utilities as LPs. All right, thanks everybody.
Thank you.
How has it been working with utilities?
Yeah, it's a fight. So we've been doing this for 7 years. We've been around a long time. There's been some bumps in the road. Utilities have this incredibly big wallet, but it's difficult to get in there. So we always say that it's a long sales cycle, but they're very sticky customers. We're finally getting to that point where we're being spec'd into rate cases. It's even like, oh, we're gonna get spec'd into a rate case. It starts in 26. So it's just, you gotta form your company and like understand what your burn is and be prepared for the long haul. Yeah, but it can be brutal at times.
Are there applications in microgrid environments?
Yes, but it's not something that we've been chasing that actively. So we actually found out about this problem because of a microgrid. There's a microgrid in Illinois. They have kind of a neat microgrid in the sense that they have real customers that were on this like 2 or 3 block stretch, and they island it, like a microgrid should be islanded. And what happened was they kept tripping off their generator, and they realized it was because of the 3-phase imbalance. It was imbalanced such that it was knocking that generator offline. And we're like, oh, well, how do you fix that? And they're like, well, we go out to the line and we take one of the wires and we disconnect it from one phase and then we reconnect it to the other and we see if we fix the problem. And then we did that 6 or 7 times over the course of 3 weeks, and then we were able to get our microgrid to run. And it was like, that is an interesting problem. And we found that this is something that just exists in their operations, that it's like, there's no good solution. So a lot of them are like looking the other way and sort of grimacing, and then they wait and wait and wait until the problem gets so painful that they have to throw $3 to $5 million at it to rebuild the distribution circuit. And it's just like, that's not a good way to run the business. So. All right. Thanks, everyone. Appreciate it.
I want to remind our utility friends in the audience to sign up for an investor slot if you want to talk to these companies. Next up is Gosan.
Thanks. What a fantastic conference. My name is Patrick, and I am on an odyssey to solar power my life. Over the last 20 years, I've been working with every solar technology to try to figure out where we can meet our daily needs. And with Gosan, we have come up with a whole ecosystem of appliances. You may recognize Gosan as the inventors of the vacuum tube oven. Cooks a meal in 20 minutes with nothing but sunshine. And basically everything we do is to try to create more resilience, more recreation, and responsibility. You guys know the story. We are all addicted to fossil fuels. We have a real formidable enemy here. And it's driving us towards an extinction. This addiction isn't helped by the fact that there is a dealer on every corner hooking us up with this material that causes 30% of global emissions is just in the transportation sector alone. So we feel like the time is now. I'm sure everyone in the room can agree. to innovate, to come up with solutions to evolve our American roadway. Of course, the electric vehicle has done a lot, a step in the right direction, but as we know, the grid is largely fossil fueled, and public charging infrastructure is kind of lagging behind. Superchargers are really difficult on battery longevity, and this is getting more and more pricey. Many electric vehicle manufacturers have tried to put solar on the vehicle. You may know you may have to wait for decades to get an Aptera. The vehicle on the bottom right of the light years is about $150,000, so it's very pricey. We've seen another angle here, and I want you to imagine that your vehicle could actually be met, all of its energy needs could be met by what we're calling solar self-charging. And this would be something that's complete, free from plugging in, free from refueling. It's totally noise-free and emissions-free, and we believe this is untenable in the near future. I used to believe this wasn't possible from a power density standpoint. Again, I've been in solar for a couple of decades, but we reran the numbers recently, and it pencils out quite beautifully. I'm joined by my co-founder, Gary Starr. Gary was involved here in this picture as the original X Prize, developing an electric three-wheeled vehicle. Wanted to go into production with this vehicle with a company called Zap Motors, and had a $300 million loan guarantee that he was fighting with Elon Musk to receive. So we kind of know what we're doing on that level. We obviously have a lot of obstacles, but we're not inventing the car here. We're just trying to put something on the rooftop. So I want you to meet the GoSun EV solar charger. Inside a 4x4 foot box is the latest in flexible solar technology that once the vehicle is parked, unfolds in 30 seconds, quadruples in size, and we're able to get over 1,000 watts. Now, it's only 70 pounds, it's super aerodynamic, and again, I want to iterate, this would meet all of an electric vehicle's annual driving needs. And so, obviously, building stuff is somewhat difficult. What's interesting here is GoSun has a wide range of customers, and we see this thing being much more than just in the EV space. It's capable of powering mobile power plant applications for work vehicles, camper vehicles, you name it, anything mobile. And we have an impeccable track record. So we've done over 12 successful crowd-funded products. We've generated over 20 million in revenue. We have raised 5 million in investment. And we expect to sell this product in Q2 for less than $2,000. And early market research is showing that it's going to scale and we'll do thousands. We know it's not for everyone, but that hasn't stopped us from fighting the fuel-free frontier. And I would really love everyone's help to try to get the cool kids driving on sunshine. Thank you.
More coffee up here?
Sorry, I'm also a solar fan and EV driver, so I appreciate the vision and interested in what type of flexible solar panels you're using and how you're thinking about locking in pricing and supply of solar panels.
Yeah, there's been a lot of unique leaps and bounds in the flexible solar space in the last couple of years. And the price point now of flexible solar is actually lower than traditional panels. And that's
Is it
largely
amorphous silicon, or what are you using?
multi-silicon, yeah.
Yeah.
And main supply chain is in Asia, but we have a real strong presence there where we can control kind of intellectual property and quality. And so our cost of goods on this product should enable us to still get a good 50% gross margin.
Can you share more about your go-to-market strategy? How do you scale?
Yeah, so GoSun has done, we originally launched on Kickstarter crowdfunding. So we're taking this to the same channel. And so that will help us kind of generate the buzz and get this all kicked off. We've been prototyping. We've been doing all the math to prepare for the launch, and that's going to be happening in Q2. And then manufacturing will take nearly another year before we're shipping units. But we have around 200,000 folks in our email, in our following, and another couple 100,000 on social as well. And then, of course, we go through the route. Since we're a direct-to-consumer company, we go through typical channels with PR and advertising and Google ads and Facebook ads and those types.
Just one thought, just as a user, is there any way to help the user know how to orient the car to get best amount of energy? Just because I can see shade being a problem, how you park being a problem.
Yeah, it'll probably help. Obviously, parking in the sun, but it'll probably get a little bit of improvement. 10 to 15% when orienting the vehicle north and south. And I think a lot of these users will be parking on the edge of the lot, so they'll be able to do that. But of course, it's sloped in all directions, and more horizontal the better in this situation. And then the panels all have bypass diodes, of course, so you're definitely getting all the power that's possible.
All right, thank you.
Thank you.
Ecotone Renewables.
What if I told you that this apple could be so much more than just food waste? Well, at Ecotone Renewables, we sustainably convert food waste into powerful liquid fertilizer and renewable energy. My name is Dylan Liu, and I'm the CEO here at Ecotone. My background is in material science and engineering right here from Carnegie Mellon, with career experience working for NASA and GE Renewables, developing and managing entire fleets of hardware systems. Food waste is a huge global problem, with 40% of all produced food ending up in a landfill. This is typically hauled over 300 miles to regional landfills. This emits over 8% of global greenhouse gas emissions, which for reference is double what the aviation industry emits each year. This is also a costly problem for both businesses and consumers, adding up to $2.6 trillion in annual costs from food waste. To address this, we've created a hyper-local solution that recaptures otherwise lost revenue and nutrients and puts it back into the food system right where it belongs. This takes form as our Zeus biodigester shown on the left and center here, which processes 12 tons a year of food waste on site and automatically detects and removes impurities like plastic, glass, metal, and rubber. These systems are managed remotely through our mobile application shown on the right, which tracks waste and carbon reduction data at the tip of our fingertips. These systems power themselves as well as the production of our signature soil sauce liquid fertilizer. This carbon-negative product improves crop yields for local farmers, and we sell direct to distributors as well as direct to consumer. We are tapping into two complementary markets of food waste and fertilizer, totaling over $270 billion in total market size. And we are already making an impact right here in Pittsburgh with 5 operating digesters from multiple commercial clients, including Meta, the City of Pittsburgh, Dunkin' Donuts, Highmark Health, and more. And as you can see from the third row here, our customers love our products and services, and we're already working with them to expand to additional locations. While our competitors wait up to 3 years for permit approvals, we get started operating day one with a fully automated turnkey solution. We are already on track for this rapid growth trajectory, now with 5 quarters in a row of 200% quarter-on-quarter revenue growth. Plotted here in white is the number of Zeus digesters alongside revenue generation in green. I'm joined by my incredibly talented team, including my two co-founders, Kyle and Elliot, our board of directors, all of whom are successful serial entrepreneurs. And on our path to becoming a leader in the sustainable waste management space, we are currently raising a $3 million price seed round led by Earth Foundry to meet our oversubscribed customer demand, expand existing revenue streams, and run additional case studies to refine product market fit. Thank you all for your time today. Happy to open up for any questions, and together let's turn the food waste of today into the nutrients of tomorrow.
Hey, beautiful pitch, and I like the value proposition. Ultimately, do you have a reverse logistics problem with getting the fertilizer back out to users, or who's going to use that locally?
Great question. So right now we are prioritizing what we call our one-stop shop locations. So customers like universities that use both the input capacity and all of the soil sauce on site. So universities, for example, are spending about $250,000 a year on fertilizers.
Well, and then at scale, though, are you going to have like depots where the fertilizer goes to, or how are you thinking about that?
Exactly, and right now we're working with 2 national distributors to iron out how much soil sauce they can actually handle. So that's really solving that volume problem first.
Sorry if I missed this. Can you talk more about who's paying for it? What's the pricing structure? And then are you tapping into the carbon credits market as well?
Definitely. Let me skip ahead here a little bit. So we set our systems up in terms of the go-to-market as a fixed payment lease agreement. So our customers pay a monthly rent, typically between $800 to $2,000 a month, to rent the equipment. And that big sliding scale is based on how much of the soil sauce they want to keep on site. And I think you had a second question there as well.
Carbon credits.
Carbon credits. So that's actually something we're working on this year to certify. What's been exciting to see is we already have very strong unit economics without any of those carbon credits included. So that's just kind of the cherry on top.
And you're presumably combusting the gas coming off the digester. How do you deal with permitting for having a combustion process and on site?
Great question. So we use it in a standard home gas-powered water heater. We have a system at the Pittsburgh International Airport. Fire marshal already came and checked it out, no concerns. So since it's all standard equipment, no additional permits needed for that. So it's all off the shelf.
Sure, I'll ask one. So composting is not a new idea. What have you done that makes it different?
The real key here is the automation. So that's where a lot of our IP is. Always happy to geek out on that as well if you want to learn more. But we know food waste is a really gross, stinky, smelly feedstock. So really providing that turnkey, fully automated customer experience has really been that key there. So there's a trash chute on the outside of the digesters. Throw your food waste right in, walk away, and never worry about it again.
Thank you.
Awesome. Thank you, everyone.
Sensible Photonics.
Okay, thank you all for the opportunity to be here today. My colleague and CEO couldn't make it, so I'm presenting on our behalf. I'm here from Sensible Photonics. I'm co-founder Paulo Hodnicki, and I'm here today to talk to you about how we're looking to eliminate predictable distribution asset failures. Power outages present a problem for everyone. In terms of direct economic costs in the US, $150 billion alone are experienced within the US. We can see as much as $5 million per hour for large manufacturers in terms of outage costs associated with it. And even though we have a need for increased reliability and throughput of electrical power, for example, with the increase of electric vehicle deployment, because of the penetration of renewables and other congestion on the distribution system, we're actually seeing an increase in blackouts by about 60% over the past 5 years. The distribution system is currently largely invisible to the distribution utilities, particularly when we talk about distribution assets such as transformers. If you look at the transmission or the residential level, we have existing sensing solutions. In this space, we don't, and the reason for that is the combination of the technical challenges of putting sensors at medium voltage and the price points associated with the large number of assets on the system. This is becoming exacerbated in recent years with the increasing supply chain constraints on distribution transformers, and so it's a real pain point for the utilities. We're looking to change that paradigm by combining just the right amount of technical capability with a low-cost sensing solution using patented fiber optic-based sensing that's capable of deployment throughout the distribution system, enhancing the figures of merit that utilities care about. We're looking to instrument assets such as distribution transformers as well as grid storage. The two key parameters that we're monitoring in the near term are thermals as well as acoustics. These are the two primary parameters that indicate asset health. By combining these with local analytics at the asset level, we can provide indicators of predictive failures as well as lifetime of distribution assets. And then by using low-cost, off-the-shelf wireless communications, we can also provide that data to utilities so that it could be integrated into broader grid analytics and grid services. In just the distribution transformer market alone, which is just one example of a vertical where this technology is relevant, we're seeing as many as 182 million transformers deployed on the grid globally at the distribution level, 60 million in the US with 1 million annually deployed, installed newly. If we assume 1% of existing units retrofitted on an annual basis and 10% of newly manufactured, that's over $200 million per year that we see as potential revenue. This is just one vertical. It doesn't include storage and doesn't include verticals outside of the distribution system. We believe that in addition to providing value to customers, which would be OEMs and utilities, there's also broader value in having more visibility on the distribution system. This includes for stakeholders such as regulators, and we look to capitalize on not just the hardware, but also the data moving into the future. The technology has been supported by more than $5 million in the last few years through DOE. There's collaborative technology partnerships with NETL and the University of Pittsburgh, where the IP originates, and there's current activity through the Alpha Lab Gear program helping to accelerate this. The founding team and the current team is very strong. It comprises successful co-founders, successful business leaders, including one of the co-founders of Lion Tamer, as well as the technologists who are interested to jump into the business when the timing is right. So currently, we are looking at minimum viable product development and pilot phase in partnership with OEMs and utilities. The next phase will be pilot production and test, our first full manufacturing, and then subsequently going into a low to full rate production for high volume sales moving forward into the next few years. We're interested in collaborations from the perspective of funding and collaborative partnerships with OEMs and utilities, and welcome you to connect with us through the QR code. Thank you.
Hi. I was wondering what feedback you've gotten from OEMs and utilities about your product, and what do they really need to see in order to scale this up internally?
Sure. So those are two very different stakeholders, obviously, so I appreciate you asking about both. I think increasingly our conversations with the utilities are they do see the value in this technology. And that is, I'd say if you asked me 10 years ago, that would not have been the same conversation. But particularly with distribution transformers, the supply chain is very challenging right now because of constraints on electrical steels and just the demand in general has really made it a pain point. So being able to proactively manage your fleet of transformers is something that's becoming of great interest. Grid storage, again, a key point. So from that perspective, we're getting very positive feedback. On the OEM side, we also have receptive partnerships as well, but our approach is really to look at it from a collaborative standpoint where we help utilities, help OEMs see the value proposition, and by partnering with them in sort of an iterative way, we can really start to drive it towards deployment.
So I think back like 10 years ago, Sentient had a device. It was like $1,000 between each transformer, and then there was people trying acoustics. And the utilities didn't say they didn't like it. They just said it was too expensive. They couldn't afford it. The acoustics never worked, and the Sentient type devices were too expensive. So fast forward a decade later, what price point are you at? How are you getting your acoustics to work?
Sure. So $1,000 is too expensive for distribution transformers, except for the more critical. Some of them only cost several $1,000s, right? So that's where you have challenges. The price points we're looking at, it's always difficult to throw out numbers early on, but we're more at the several $100 level or lower in terms of the sensing technologies that we're looking to deploy. The acoustic-based sensing method, it is a fiber optic-based, and we have a device architectures that let us reduce the cost of the optoelectronics that try to get it down to that price point.
All right, thank you.
Thank you.
So we just had a lot of really exciting and brave people get up and bare their souls to us. Could you please give them all a big round of applause? And then another round of applause for our panel here. We pressed into double duty here to do this as well. So what's going to happen next is we're going to have a little break. And during that time, these startups and all of the investors are going to go to the Danforth room. And again, go at 3 o'clock. 3 o'clock. We're going to start down there at 3 o'clock. We're going to go out of here, turn left again in the main corridor, go all the way down that long corridor through the cafe area. You think you're in the wrong place, but keep going all the way to the end. Each company is going to have an assigned spot. The investors will rotate around. So investors, you have a couple more minutes here to sign up for slots. Lots of exciting companies. Don't let them sit there without anybody to talk to.